7 weeks, we have had deuterium fusing to helium-4 and given this excess temperature of about 35 degrees centigrade, which is big, a really big effect. Now, in the bottom of this vessel, which is heated in this jacket, there's about 40 or 50 grams of palladium on activated carbon catalyst. And this run is now continuing and maybe will continue for some weeks or months still. The idea is to test the reliability of the catalyst. The catalyst must work for some months, or it's not a viable commercial process.
This experiment very much follows along the thought process of Les Case. And behind me you see 5 different sets of apparatus. The big vessel here is one of Les Case's, he calls them footballs. It's a stainless steel vessel on a heating mantle set up in exactly the arrangement that Les Case himself is doing in New Hampshire. On the monitor you see displayed, in fact, the mass spectrum from one of these samples. This is a relatively high level of helium-4. We compare the samples each day that we perform the analysis. We compare the sample of gas from the various active cells and blanks with a sample of room air, which we have measured many, many times and know to be 5.22 parts per million. If the helium is produced by a nuclear process, then necessarily there will be an associated release of heat. It appears that, yes indeed, in the vessel that was producing helium, there was some evidence of excess heat, and that the amount of heat produced was approximately quantitatively correlated, that is, the right amount of heat was produced compared to that of a nuclear process involving deuteron plus deuteron producing 1 helium-4 nucleus, which releases 23.8 million electron volts.
My objective always has been not to play around scientifically, because I'm not really a physicist, but to head towards commercialization. And I really want to go to 100 megawatt reactors, maybe in 2 or 3 years, which is really compressing the time scale, but it's maybe possible. So the idea is to scale it up.
The technology of catalytic fusion developed by Dr. Les Case is one of the most extraordinary developments we have in the cold fusion field. He has excess heat, massive excess heat, repeatable excess heat, clear null results, and also helium-4 production. Production of the very nuclear ash that the opponents of cold fusion demanded in the early days. Now we have it in spades. It appears as though he is very close to having a self-sustaining device that will keep hot by itself, generate steam, hot water, perhaps electricity, before much longer.
An experimentalist who has pioneered another promising cold fusion method, sonocavitation, is Dr. Roger Stringham of First Gate Energies. Using ultrasound frequencies, Stringham has observed extraordinarily high temperatures caused by the process of cavitation, where microscopic bubbles in water tunnel their way into target metals. Metals like silver, titanium, palladium, and platinum are melted by intense heat created during the brief moment it takes for a bubble to collapse.
Well, this is a cavitation process going on in the bubble, and the acoustic energy is absorbed by the liquid, and there is a certain point in which it creates small voids which actually grow and then collapse very rapidly. And that is the cavitation idea. The temperatures that are required to create these ejectocytes are at least the melting point of the metal, and it looks like we are actually in the vapor phase, which is gaseous metal, and this amounts to, for the liquid metal, 1600 degrees Kelvin, and for titanium higher. For the vaporous state is several thousand degrees higher than that.
Stringham is seeking to commercialize his device for use as a home power multiplier that can supplement conventional electric power usage. Transmuting base metals into new, more refined elements was once the long sought-after effect of the medieval alchemists. Turning lead into gold was a mythical dream until modern science proved that it could be done, although it required an immense amount of energy, making it highly impractical. Yet as early as 1992, cold fusion experimenters began reporting unusual appearances of trace amounts of different metals such as copper, silver, chromium, and zinc when examining their spent cells. Rechecking for possible contamination, scientists like Botras and Miley confirmed that indeed new metals and isotopes were being formed, transmuted, during the process which produces excess heat.
Kevin Wolf made many measurements of tritium. Then he got some even more astonishing results as early as '92, which were these transmutational results, the metal forming another metal inside the electrode, you see, which was super anti-paradigm. You know, there's that dreadful word alchemy, which we mustn't use, but it was a form of that in a way, that was creating new metals, you see.
In Japan, Tadayoshi Omori and Tadahiko Mizuno at Hokkaido University have produced volumes of data under rigorously designed experiments showing the production of metals ranging from iron to platinum and beyond. The Omori cell using a tungsten cathode has consistently produced excess energy along with measurable amounts of transmuted metals.
Once considered heresy, scientists are discovering that even heavy elements may be transmuted, opening a whole new world of possibilities. Companies like SETI and the Cincinnati Group have drawn the attention of the U.S. Department of Energy by developing processes that remediate radioactive waste. As with the current revolution in genetics, science is beginning to understand that we soon may be able to rearrange the most fundamental units of matter in any way we wish. Science fiction is quickly becoming science fact.
If these new sources of energy do turn out to be real, and I say there's possibly several totally different varieties, the question is, what effect will this have on our society, on the future? Well, it's just possible they may be no more than laboratory curiosities and can't be scaled up to commercial levels. I think that's rather unlikely. Nuclear energy was once a laboratory curiosity. So let's assume that these devices can be developed. The future is then almost unlimited. It could be the end of the fossil fuel age, the end of oil and coal, and the end, incidentally, of many of our worries about global pollution and global warming.
Right now, 2/3 of the cities has problem in pollution. And 1/3 of the land of my country is damaged by the acid rain. 80% of the power energy source is from coal. So this is a big problem. And right now we have 1.2 billion population. And we anticipate it will be 1/2 or more billion in the middle of next century. Right now, we consume 1 ton of the coal per capita. If we increase our power consumption by a factor of 3, we will burn about 5 billion tons of coal in the middle of next century. That's why I made my mind to do this cold fusion research. It's a big risk for me, but I think it's worthwhile to do it.
But what I like about cold fusion is it is different from thermal power, hydroelectric power, or nuclear fission power because it is potentially small, and the investments required are much smaller, and hopefully it can be mass produced by industry. And this completely changes the whole concept of power generation, distribution, consumption.
Examples of how these new energy technologies will replace fossil fuels are already in commercial development. In Vancouver, a small manufacturer of hydrogen cells called Ballard Power Systems has convinced major auto companies to switch to a system which is both non-polluting and eventually will be more economical. Although it is not a cold fusion device, the fuel cell is an interim technology that has been around for 150 years, but was only recently developed due to advancements in technology and the global environmental imperative. Cold fusion cells could easily take a similar pathway into the marketplace, with far more profound consequences, because it is millions of times more powerful than chemical energy per gram of fuel.
If we have a new energy source like this, which is capable of being made in very small units on up to large units, that's going to revolutionize our future energy supply. And energy is still basic to man. It's basic to our standard of living. And also, if it's a type of energy that doesn't pollute in terms of fossil fuel, CO2, greenhouse effect, all these things, as at least we currently envision the cold fusion energy source would do, it not only will give us this future energy source, but it's going to help us be good stewards of our universe.
Many now fear our global climate may be changing, largely as a result of fossil fuel combustion. The imperative to find non-polluting energy systems will continue to exert pressure on all sectors of industry and government. The very fate of life on Earth is at stake.
Today, we can no longer say that the evidence is overwhelmingly compelling. It is now 100% certain. There is just absolutely no doubt about this. Commercial activities are underway to develop this new scientific phenomenon, which we certainly still do not fully understand. I believe the phenomenon will be developed irrespective of whether we understand it. Already there are several commercial units that appear to have energies in the kilowatt per cubic centimeter of material range. We see transmutation phenomena. We see helium-4 production. We see a range of methods of getting the excess heat. But at the same time, the establishment, the scientific establishment, appears absolutely deaf to all of this evidence. So I conclude that the only way that cold fusion will be triumphant will be in the commercialization. I think the electric power grid will absolutely wither away. I think automobiles, trucks, trains, planes, all forms of transportation will use this new powerful energy source, whatever its exact nature turns out to be. The writing is on the wall. The fossil fuel age is about to end.
It's history in the making, what we're living here. I mean, I couldn't dream of a situation like that. Can you imagine living at the time of Einstein and Curie and Bohr, all these great people who were changing completely the science at the beginning of the century? And when I was going to school, to college, and all these things, it was like, it's over now. Everything is done. Just shut up and learn. And now, all of a sudden, I know that I don't have to shut up, and I can do something in the field. I can bring my own contribution.
There's a curious parallel back at the beginning of the century. When the Wright brothers first flew in 1903, no papers covered it at all, because everybody was convinced, certainly the American press, that heavier-than-air flight was totally impossible. All the top scientists said this is nonsense. And editors wouldn't even bother to send journalists or photographers to interview the Wrights, or even to take pictures of them flying in full public view. And it wasn't for about 5 years that eventually they realized, my goodness, this is real. Heavier-than-air flight is possible. And I think a similar thing is going to happen with so-called cold fusion.
Will cold fusion remain an intriguing curiosity, woefully underfunded and eclipsed by other exotic alternative energy processes? Or is there a long-range position for it within a diverse spectrum of 21st century non-polluting technologies that will make living in the third millennium more of a utopian dream, once envisioned by far-thinking science fiction writers like Jules Verne and Arthur C. Clarke? How much courage our scientific and business leaders summon today may very well determine how the human experiment on planet Earth will fare. Think about that the next time you drink a glass of water.